All right, great. One more video for video lecture 19, and this one we're going to focus on the Pythagorean theorem, something you've probably done before. But real quick, just to, kind of formalize what we're talking about here. So the Pythagorean theorem is a special relationship um, specifically related to right triangles. So we have to have right triangles here. Um, and it is talking about the distance of the sides of that right triangle, okay? And something I like to show, like where this, one of the ways to show it at least. So I've got a specific right triangle here. This specific right triangle is three, three dots long here. It has a height of 4, and then this longest side is going to end up being 5 units long. So this is a right triangle where the sides work out to whole number lengths. It's called a Pythagorean triple. It's special. But a way of showing you what the Pythagorean theorem is talking about. So we all know it as a squared plus b squared equals c squared. And we'll get to this here in a moment. But what we can show that as is, right, a squared. So if I took this 3, right, the one side's 3, and I built a square on that side, what's the area of that square? That square is 3 by 3. There is 9 blocks on the inside of that. And if I did b squared, right, if I put a square on the side of this other side, 4 by 4, that square would be 16 blocks. It'd have 16 blocks in it. And the Pythagorean theorem is saying, well, if we add those two things together, 16 plus 9, that should equal how big the square on this final side would be. And if I built a square, excuse my drawing here, right, it would be 5 by 5, and 5 by 5 would give us 25 blocks, okay? So Pythagorean theorem is formalizing this relationship, and it works for all right triangles. So it's saying that a squared plus b squared equals c squared, where a and b are the legs of a right triangle. So it's the two shorter sides, and c is the hypotenuse, which is the longest side, and that longest side will always be across from this right angle. Okay? So that's what we're going to be using today. Have it in your notes that we are solving for side lengths. That is what the Pythagorean theorem is used for. Okay? So, and A and B have to be our legs, our two shorter sides of that triangle, and C is our hypotenuse, the longest side. All right, let's do a couple examples. We're going to be able to solve for a missing side. So, if you see a right triangle and it's missing a side length, we know we can use the Pythagorean theorem. Main thing is you have to identify which are your legs and which is your hypotenuse. So in this case, right, the ones that really matter is being able to identify the hypotenuse. So if you go straight across from your right angle, that is always your hypotenuse, your C. Okay. A and B we can put in whatever order they're getting added together. So order doesn't matter here. All right, so I'm going to put in a 10. I'm going to put in a 12. And c squared is the one we don't know. So that's the one we're solving for. And you can put an x squared there if we would like, okay? I'll go ahead and do that. All right, so now we square our stuff. We get 100, we get 144. We can add those two things together. We get 244 equals x squared. So now we've, I think we're good up until this point. So what this is saying is that the square that would get built there, it would have an area of 244. We now have to figure out how big is the side. And so it's saying something squared gave us 244. So really what we need to do now is we need to undo that squared. Anybody know what the opposite of squaring something is, or what would undo a squared? We would want to square root both sides. So in this stage, we're going to square root that 244. And the square root of 244 is about, I think they tend to tell you to round to the 10th place, so to one decimal place. So we're going to do 15.6 here. When I typed it in, I got 15.62. So we're going to leave it as 15.6. Okay. All right, let's try another one. So in this one, right, let's identify what we have. So if we go across from our 90-degree angle, we see that we do have 15. That's our C. And then we're missing one of our legs. So either A or B, it doesn't matter which one we label it as, okay? I'm gonna go ahead and label it as A, and then I'll label this as B. So A squared plus B squared equals C squared, filling in what we have. So we have X squared, we have 9 squared, 15 squared. All right, let's go ahead and work out what we can and try to get X by itself. We're gonna solve. So we got X squared, 9 squared, we can do that, that's 81. 15 squared, 225. All right, to get X by itself now, we are going to move that 81, so we would subtract 81 from both sides. So we get X squared equals 144. Our new step today, kind of, right? We need to undo the squared, so we would square root both sides, and the square root of 144 is 12. So we've got a side length of 12 for this one. This is another Pythagorean triple because all of the side lengths are whole numbers. We got 9, 12, 15. All right, cool. Let's do a couple of other type of problems. We've got a couple of word problems that we're going to get into. So go ahead and pause the video, get this question written down, get that picture drawn. So you'll see several of these in the homework, but they'll have a nice picture drawn for you, and essentially, right, that they've done a nice job of telling you what you're solving for, and they've given you a nice picture. You are going to encounter things here in later on in the class where you have to draw that picture for yourself. Okay, so make sure that you're going to be able to read something and draw your own picture. All right, so let's identify what we're being asked to find a side length of a right triangle, so that allows us to use Pythagorean theorem. If we're identifying what we have and what we're missing, we go across from the 90-degree angle. That is our C. That's our longest side of this right triangle. So we know we're going to fill in 11 for C. We're missing an A or a B. So again, I'm going to leave A as the thing I'm solving for. I'm filling in 6 as my B and 11 as my C. Go ahead and start solving. We got 36. We got 121. We're going to subtract 36 from both sides. So we get A squared equals 85. And then we're going to square root both sides. So the square root of 85 is 9.21. And it wants us to round to a tenth, so it's 9.2. Okay. You notice that they went ahead and put the label for you there of feet, but just be conscious of what we're doing here, right? We're measuring a length, just a side, so it would just be like those single units, just feet. Okay. All right, let's do one more. Go ahead and get that written down. Get yourself a picture drawn. But again, if we're being asked to find the length and it's a right triangle, we're able to use the Pythagorean theorem. All right. Going across from our 90-degree angle, we see we are told a 36, so that's going to be our C. I'm a creature of habit, so I'm just leaving my A blank. I know it's a leg that I'm solving for. All right. Definitely going to need a little calculator action here. So we've got 32 squared, which is 1,024, and we've got 36 squared, which is 1,296. All right, again, we're solving for A, so we're going to move that 1,024 over. And so we get that the square of A is equal to 227. We finish it out by square rooting to do the opposite of squared. And we've got 16.49 is what it comes up as. We need to round to the nearest tenth, and 49 would round to 0.5. So we need to put 16.5. I'm going to put a little m here since we're measuring in meters. Okay. Great job with that. Our problem when we get to class. So I got a doozy for you. It's a good one. So Sid somehow owns wolverines and badgers. I don't know if it's legal. But Sid is building a pen pictured above, okay? There must be fencing separating the animals. Otherwise, wolverines and badgers will not get along. So that dotted line, make sure that, there's fencing there. It creates two smaller triangular pins. So Sid received a quote for fencing at $14.60 per foot. How much will it cost for Sid to build this pen? All right, so use some of the skills that we've developed throughout video lecture 19. Give this a good try. We're going to do this in class, okay? So have some ideas and we'll be able to discuss them. All right, great job. Take care. Have a good one.